Algebra 1, KCS at Home, Summer Edition, Polynomials Part 2. Andrew Turner here at Central High School, wrapping up our very last section of Polynomials. Email me at andrew.turner this summer if you have any questions over your packet or anything that's in the contents of this video series. So the last video we were talking about multiplying two polynomials together. We're going to be basically doing that a little bit backwards. You know, when we're talking about factoring, factoring really means how can you rewrite it based on multiplication. For example, what are the factors of 6? You'd be thinking, well, 2 and 3, and that's because 2 times 3 is 6. And so we're really trying to think of, well, how can we rewrite where you're basically having two parentheses with two terms in each one, kind of like what we call binomials, two binomials that multiply together to produce this exact quadratic. So the first thing we want to talk about in the model is kind of like in the quadratic section we talked about standard form. You have your A, B, and C. So in this problem, A is 1, B is 5, and C is the number 6. And so if you remember in the last video we were talking about, let me go back to that, we were trying to think about, okay, well, what we have in the parenthesis, we're going to multiply together. Well, we're going to kind of think backwards and think, okay, we already know what we have as an answer when they multiply. What would have multiplied if we were to move backward? So this is your x squared and your 6 that's kind of in here. But the way that we really think about factoring is we really lock in on B and C. These terms are very helpful, especially when A is a leading coefficient of 1. For example, this is just 1x squared. And that makes the problem a lot easier for many students. And so the first thing we want to lock in on is that C is 6. So we're trying to find two numbers that would ultimately multiply to be 6. But that B term, that number in the middle, was 5, and we really need to think, well, what numbers would add to be 5? And they need to be those same two numbers that multiplied to be 6. And so if you think about the factors of 6, 6 could either be 1 times 6, or it could be 2 times 3. Now, which of these adds to be 5 would be the correct answer, and that would be 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. And so when we think about this 5x in here, we really need to think, okay, well, that had to have been 3x plus 2x. And so now we've kind of broken apart that middle term and thinking about, okay, what would have multiplied to be 6 while adding to be 5, and then we can do that greatest common factor part looking at each part of the grid. So for example, x squared and 3x, what do these have in common? They both have x in common, okay? Well, what if I said, well, what does x squared and 2x have in common? If I was looking up and down, well, both of those have x in common, okay? Well, what if I looked here? What about 3x and 6? What do those have in common in terms of greatest common factor? Well, they have a positive 3 that they have in common. And 2x and 6, what do those numbers have in common? They're both divisible by 2 and positive 2. So now we kind of have our answers on the outside of the box. We have x plus 2. That was one of our answers. And the other one we had was x plus 3. And we can check to make sure that this multiplies together correctly to be what we started with before we move on. So x times x is x squared, x times 3 is 3x, 2 times x is 2x, and 2 times 3 is 6. And when you go to combine like terms, you do in fact get 5x, just like we started with. So I know that was a lot. Let's do another problem kind of breaking that whole situation down a little bit more. So in the multiplication box, we know that we'll get x squared at the beginning, and we'll also get negative 10 at the end. But we're trying to find two numbers that would multiply to be negative 10, but when we add the two numbers together, we get negative 3. So the negatives definitely make this a little more challenging. But let's start with the 10. You know, to get 10, you got 1 times 10, or you have 2 times 5. So how can you add or subtract some form of these numbers, either positive or negative, to ultimately get 3, negative 3 when you add them together, or when you multiply them together, you get negative 10. So for example, to multiply to be negative 10, one of these is going to have to be negative. Maybe it's the 1, maybe it's the 10. But when you add 1 and negative 10 or negative 1 and 10, there's no way you're going to get that to negative 3. You're going to be getting like 11 or negative 9 or negative 11 or positive 9, something like that. But if you think about 2 and 5, 2 times negative 5 is negative 10, but 2 plus negative 5, that is also going to add to be negative 3. So that means in one of these boxes I need negative 5x and the other one to be positive 2x. Now these are both linear terms because when you add them together, you're getting that middle value of negative 3x. Okay, so now we're going to do that GCS part in all 4 directions. So I'm going to do that here. X squared and negative 5x, those both have x in common. 2x minus 10, those both have 2 in common. Thinking vertically, what do x squared and 2x have in common? Those both have an x that they both have in common. And negative 5 and negative 10, if you're thinking about these values, they both have negative 5 in common. Negative 5 times 1 and negative 5 times 2. So now I have kind of extracted my greatest common factors, if you will, and I have x plus 2 and I have x minus 5. And I can go through a quick check again, you know, just to make sure that when these distribute together, that everything multiplies correctly, that everything combines to be the right like terms that I'm supposed to get. That is exactly what I start with in the very beginning. Okay, so I think before we go to a totally different problem there, just make up a few real quick, a little faster outside of the model. You know, once you really understand how this works, we're trying to multiply to be C, we're trying to add to be B. So in this problem, we're trying to multiply to be 3 while adding to be 4. And so thinking about 3 times 1 is 3. 3 plus 1 is 4. So this would ultimately factor x plus 1 times x plus 3. So if you can lock in on what we are trying to multiply to be and what we are trying to add to be, that can make it a lot quicker. Let's say this middle value had been a negative 4. Well, still multiplying to be 3 times 1, but really now you need them to both be negative. That way, negative 1 plus negative 3 is negative 4. Negative 1 times negative 3, that makes positive 3. Let's do one more. Let's say you had x squared plus 12x plus 20. Want to think what all multiplies to be 20? 1 times 20, 2 times 10, 4 times 5. Well, which of these could add to be 12? Not 1 and 20. Not 4 and 5, x plus 2, x plus 10. We just successfully factored this quadratic. So what is slightly different when you are talking about a number that's not a coefficient of 1? So we're going to talk about what's called the AC method. It's something that I teach every year. And so when we talk about the AC method, we need to think about, well, how are we going to begin this problem because A is not a coefficient of 1? Well, really, you could call this other process a coefficient of 1 AC method as well because A is 1, and whenever you're starting the AC method, you're going to start by multiplying A times C. So 6 times 4 is 24, and now that's kind of our targeted number for multiplication. What would multiply to be 24 while adding to be that middle number of 11? And so really this can be something that you do every time. You know, what multiplies to be 1 times 3, 3. That's just a kind of an unnecessary step a lot of times when that value is a 1, but when that value is something other than 1, like in this problem 6x squared, we need to start by thinking about what is a times c. So when I think about 24, I'm thinking 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are all the combinations that multiply to be 24 using integers. But 11 can be produced by only 8 plus 3, while doing 8 times 3 to be 24. So in this method, what I'm going to basically do is I'm going to replace my b term using the 8 and 3. I've got 6x squared, but instead of putting 11x, I'm going to put plus 8x plus 3x, which technically is 11x. With my 4 at the end, I have everything that I started with. So what this allows me to do is kind of separate my terms. Instead of having 3, I have 4, similar to the 4 that you have in the box method. It's really the same concept, honestly. What we're going to do is we're going to think about this as GCF, greatest common factor, but only in groups. So what would the GCF be of 6 and 8? Well, 6 is 2 times 3, and 8 is 2 times 4, so both of these have a 2 in common. Well, but it's not just 6 and 8, it's x squared and x. And so one of them has 2 x's, one of them has 1, so it's like they both have up to 1 that they have in common. So when I divide 2x from each of these, 6 divides by 2 to be 3, and the powers subtract for division, 2 minus 1, I've got 3x now. So 2x times 3x, that is 6x squared if you were to distribute. Continuing with our division for GCF, 8x divided by 2x would be positive 4, no x's there. You get the x from the distribution when you multiply 2x times 4. And so when I look at this next one, I'm looking to see, well, what do these have in common? Well, 3 and 4 do not have anything other than 1 in common, 3 times 1 and 4 times 1, and they both do not have an x in common, so really the only thing I can take out is a 1. And this kind of seems like, well, why would you take out 1? It doesn't change anything. Well, it really helps me to see what my final answer is, because if you notice, 3x plus 4 has repeated itself. It is in both of my answers, or both of my GCF factoring parts, and that actually makes up one of my answers. And you can put it in either one, it doesn't matter. But what you took out of each one, that 2x that you had in the front, that plus 1, that creates your other binomial. And so this is now successfully factored. So let's take a moment just to check our work. We want to make sure that when you multiply these parentheses together, you get exactly what you started with in the beginning. So I know I showed multiple methods. I think I'll go back and show the box method again. Let's say we're multiplying 2x times 1, and we're multiplying 3x and 4. So we're basically going to multiply each of these together. 2x and 3x makes 6x squared. 3x times 1 would be 3x. Now we're sliding down. 4 times 2x would be 8x. 4 times 1 is 4. And now we're just looking to combine like terms as we see them, and I'm really looking at the middle there, these 3x and the 8x. So 6x squared plus 11x plus 24. Plus positive 4, my fault. And that is exactly what we started with. So just knowing that you can check your work with multiplication is very helpful. Okay, let's talk about some difference in perfect squares. These are kind of special type of problems because they're dealing with what we call perfect square numbers. For example, this would be x plus 5 and x minus 5. When you multiply those together, there's some symmetry that cancels out in the middle, leaving only x squared minus 25. For something like this, you may have to start with GCF to realize they all have 3 in common. Let's divide everything by 3. And then again, 100 is a perfect square. The square root of 100 would be 10. So this could be x plus 10 and x minus 10. Okay? I'm going to stop the video and finish the rest of it in one last video so that I'm not rushing this last part. So I'll see you in just a minute.